Antigravity is the ultimate vibe coding engine, but you don't have to break a bank just to afford AI token credits or costly monthly subscriptions in order to build your dream project. Today, we are ditching the very costly default models like Gemini Pro, Claude, and OpenAI's GPT. We are setting up custom state-of-the-art large language models. Let's get to it. In order to optimize your workflow or scale your business and build high-end software like our courier cargo tracking platform, which we'll be experimenting with later in this video, you have to understand a fundamental shift in technology. Standard editors like VS Code are simply text boxes with AI plugins slapped into them, while Google Antigravity is entirely different. It is an autonomous agent that happens to have an editor attached to it. When you give Antigravity a task, it doesn't just output a snippet of code in a sidebar. It maps out your project file tree. It coordinates sub-agents and dynamically modifies your workspace files. But here is the catch. Look at this cloud model usage tracker right here. So Google wants a transaction fee for every file change. If your agent makes a mistake and loops 5 times, you pay for those 5 mistakes. We are going to bypass that right now by deploying a local terminal backdoor. To route this enterprise ecosystem directly into our local machine, we are installing an open source bridge called OpenCode AI. This tool sits right inside our workspace directory and lets Antigravity interface communicate directly with our Ollama server. So in the previous video, I provided a quick guide on how to install Ollama and pull in the current state-of-the-art models like Qwen, DeepSeek, and Gemma 4 by Google. I've also provided necessary resources for this video like the commands we'll be providing in the terminal and other valuable resources. So next, I'll open Antigravity's terminal and let's run a short code. So here we are in Antigravity's terminal. Now here is the command to install our open source bridge, the OpenCode AI. And there we go, we have it in progress. And just like that, we have OpenCode AI installed via our Antigravity terminal, and it added 3 packages in 16 seconds. So once the package is globally installed, we need to map it directly to our workstation custom Ollama model ecosystem. Since we want to build highly robust multi-file applications, we aren't going to use lightweight models. We are calling the king of local reasoning, Qwen 2.5 Coder 32 billion instruct, as well as other heavyweight models for top-tier agentic use case. So we'll configure OpenCode to bridge our provider Ollama, which gives us the possibility to use open source local models on our local device. Now, we'll be setting Qwen 2.5 Coder, DeepSeek R1 14 billion parameter, as well as Gemma 4 26 billion parameter. And let's set. And here we have the configuration in progress. Once the configuration is done, let's confirm the status. So we simply type in OpenCode status. And just like that, our status check is complete and we have the update. Now, if your device is running on an 8GB video card, like my NVIDIA Quadro RTX 4000, pulling the 32 billion parameters means Ollama will split the weight across your system RAM. It will take an extra few seconds to think compared to lesser weight models, but the 32 billion parameter possesses strict tool calling logic that won't drop broken code fragments or chat text into our file tree. Now, let's execute the ultimate hybrid workflow. We use Google's free tier cloud model, Gemini Flash, exclusively to handle the macro level or high level project planning. Flash has a massive context window and costs us nothing to generate a text plan. But instead of letting the cloud agent execute the physical coding changes on our hard drive, we then pass the blueprint down to our local terminal sidebar. So I'll provide my high-level prompt. Here, I'm giving it a persona. Then I proceed to say I'm building a high-end premium courier cargo tracking dashboard for alien tech digital services using Vite, React, and TailwindCSS. So I'm proceeding to say generate a complete macro-level project plan and component architecture map for my source. So I provide the source, which will be creating a file markdown. Then I proceed to give it some more tips, like the various features, the shell and navigation, the cyberpunk theme variables, high-state input sections, and all that. Then I say, only provide the architectural blueprint and state definitions. The do not generate code blocks restriction here is very important. This is a secret mechanism. It forces the cloud model to spend 100% of its generation context on structural logic, layout maps, and state definitions rather than wasting our free tier usage printing generic code. Now I'll submit my prompt. And here we have it in the thinking state. And almost instantly, it provides a response. Now, let's check out its response. It says, I've generated a comprehensive project plan and component architecture map for your cargo tracking dashboard. The complete blueprint has been saved as an artifact at projectplan.md. Below is the structured architecture map and state definition designed for direct ingestion by your code generation agents. So it takes note, it is just generating the high-level project plan while our code agents will then proceed with the execution. And it states the various steps like the share and navigation, the cyberpunk theme and layout setup, hero state input section, main analytics grid, interactive shipment timeline component, and other steps. So clicking on project plan, it displays our entire project plan right here. Now, with our project plan ready to go, let's create our project skeleton setup. I'll navigate to our terminal and I'll provide a short command. Now it gives a response. It needs to install the following packages to create the Vite project file structure. We type in Y and approve. And here we have it in progress. It's scaffolding our project structure in the folder we just mentioned, Alien Cargo App. And now it's installing our project dependencies with npm. npm here simply means Node Package Manager. It's the default package manager for JavaScript runtime environment, and it consists of two main parts: the command line interface we are currently using and an online registry. And now our packages have been successfully installed. We'll give a command to change directory and make sure we are in our newly created folder, the Alien Cargo App. So cd here basically means change directory, and we'll be moving into the Alien Cargo App folder we just requested to be created. Now we'll proceed to the next step, installing our TailwindCSS setup requirements and proceed. Quick tip here, as you can notice, our terminal is currently dormant. This is because after creating a high-level project structure, it automatically launched a local development server on port 5173. You can see the green server logs on the left side here. So because that local server process is active and running in the background, the terminal tab is completely occupied. We could easily terminate the background server by typing Ctrl+C on our keyboard, but it's preferable to leave the server running and instead start a new terminal window and proceed with providing our commands. And just like that, our setup executed smoothly. It has installed 47 packages as well as it found 0 vulnerabilities. So currently we are good to go. Next, we'll install one final configuration command to initialize and make sure our TailwindCSS and our PostCSS works together in our project. So the command is npx tailwindcss init p, and let's run it. And there we go. Our two main requirements have been created smoothly. In the response here, we can see created TailwindCSS configuration file and created PostCSS configuration file. Now, if you had noticed on the left sidebar here, all along, we have had this notification showing you have not yet opened a folder. That is because we had not yet initialized our high-level project file structure or our project skeleton. So now that we have initialized in the folder Alien Cargo App, I'll quickly access the folder we just created. And just like that, our interface spins up and brings our entire project file structure to life in our file tree. Here's a quick way to include our project plan in our current file structure on our left sidebar right here. So we can do this by accessing our chat history. And here we have it, the cargo dashboard architecture. And all we need to do is navigate to the project plan file. Once we click on it, it populates the entire project plan. So we can basically copy this entire plan into our clipboard. As we can find it here, copy to clipboard. And back into our project structure, we can create a new file. Creating a new file, we have to name it exactly the same, project plan. And I'll open the file. Then paste in the project plan we had generated earlier. So again, I'll copy to clipboard and paste it directly into the new file we just created. So tapping Ctrl+V, paste in the text we just copied to our clipboard. And here we have it, projectplan.md, sitting right into our project structure. After getting our entire file structure and project skeleton or template ready, now is the moment of truth. I'm launching a new terminal window and I'll run an Ollama command, Ollama list. This will list all the models we currently have installed in our system. So like I mentioned in the previous video, I had shown how to install Ollama and as well pull any open source model you intend to use. So to make sure Qwen 32 billion parameter instruct will be the one executing our next prompt, let's make sure it is currently at the steering wheel. We'll run a quick command, opencode config set model Qwen 2.5 coder 32 billion parameter instruct. And there we go, we have it ready to use. So here's my prompt. Implement the complete premium cargo tracking dashboard components inside source app.jsx based on the sidebar plan. So our local model here is well aware of our entire file structure we just created earlier. So I'm specifying in the source app.jsx folder. This is our source folder right here. And here we go, our prompt has been received and work is in progress. And just like that, our entire code has been built completely. And it doesn't just build the code and leave it to us to implement into our project. It does everything and verifies. As you can see here, it updated index.html, it fixed Tailwind config, and all that. Now to preview the result, we provide a simple command npm run dev. This spins up a local development server right from our directory. So it is currently running at localhost 5173 and we can click the link to preview. And just like that, we have a result. Based on our prompt, the Cyberpunk cargo tracking dashboard can see it is customized based on the theme we use in our prompt for this project. We'll head back to Antigravity and launch a new terminal window. Here, we'll provide a prompt making sure our app is converted into an actual corporate real-life cargo tracking dashboard. So I'm saying opencode, making sure to mention and providing a prompt. Completely rewrite the source app to replace the cyberpunk aesthetic with a premium, clean, real-world, corporate glass morphism, liquid glass UI design. And make sure to give it directive to ensure these strict UI specifications. And just like that, we can see in real time our user interface has been updated properly. We can see it shows now and aligns with real life use case. Like here we can see express electronics delivery, priority medical cargo in transit, standard retail freight, and more details like package weight, route from London to Manchester, estimated delivery. And here we have the shipment timeline. And this is quite awesome. Working all free, no subscription, and $0 paid. Now let's check our model quota and confirm. And right here, we can see our available quota and I'll refresh to make sure. So after all the configuration and the various prompts we have provided to Antigravity and even completing our build, we can see here our available model quota is still at 100%. And just like that, we have successfully broken free from API limits, subscription tiers, and restrictive credit systems right on our own workstation. So now you have mastered the hybrid framework. But what if these AI tools could work for your business or complete your projects while you sleep? In our next video, we'll be taking the ultimate leap, building an entirely automated local AI engineering team using Docker containers and OpenCloud. Do well to support our efforts with a like, subscribe, and I'll see you in the next video. Cheers!